Good morning, everyone. How are you guys doing today? I'm doing fine, thank you. So, we are not done with the materials for our next exam. So, my plan for today is to finish these inequalities, and then we're going to do a review if you have time. And definitely, I'll tell you what will be in the exam. I feel like this exam is a long one, so you have to be prepared to answer everything faster than your third exam. Third exam was the simplest exam, the shortest exam, but this one is a little bit longer. And it's a little bit longer because most of the question here will be in the final exam. So I don't even know which one to skip. I cannot skip anything, so I'm going to give everything what will be in the final exam. Okay, so this is 11.4 or something, solving inequalities. Previously, we did solving inequalities for quadratic. And when you have a quadratic equation, for example, if you had ax squared plus bx plus c, if you have this type of inequality, all you have to do is draw the graph and then figure out what portion they're asking for, okay? But right now, the question we are going to do, they are not quadratic, so you cannot use graph to find a positive or negative part. So when you don't know the graph of your equation or the function, that time you need other methods to find out the positive portion or the negative portion they're asking for. So what do? We use number line. Before we find number line, first we need to find all the x-intercepts. To define x-intercept, we take each factor, set them equals to 0, solve for x. And then we plot them on the number line. And then we are going to test each interval to check which interval gives us positive y or negative y. Here we are looking for positive y. So we are looking for positive y or 0y. Y is positive or y is 0. So we are going to see where our y's are 0 and where our y's are positive. We are going to take those intervals from the number line. Okay? So step 1, finding x-intercepts. And we know to find the x-intercept, we set y to be 0, solve for x. So here our y is already 0. So you take each component and set them equals 0. The second one is x plus 1 squared. We set it equals to 0. The third component is x minus 4. We set it equals to 0. So set each factor equals to 0 if it's already in factored form. If it's already in factored form, we don't have to do any math. We go find the x-intercept right away. But if it's not in factored form, our first step should be bring everything to one side so that you can factor. Once we have your factors, then find the x-intercepts. So this one is already alone for x, so you don't have to do anything. For next one, we take the square root on both sides, so square root and square cancel out. We get x plus 1 equals 0. That gives us x equals negative 1. For the third one, we add 4 to both sides, so we get x equals to 4. So our y is 0 when x is 0, negative 1, and 4. So we found when y is 0. And now we need to know when y is positive. So to figure that out, we are going to, let me write the number first. We have x plus 1 squared, x minus 4. So let me put the number line here. In our number line, the smallest number on the left is negative infinity. The highest number on the right is positive infinity. We are doing inequalities, non-quadratic inequalities. And then we are going to plot all those points. We have -1 somewhere here, 0 somewhere here, and 4 somewhere here. We plot them, and then we figure out which interval gives us positive y. So we test each interval. We take an x value from the first interval and substitute here. So what numbers we get from -infinity to -1? Give me a number from -infinity to -1. -2. Basically, they are asking pick a number that is smaller than -1. So this x is -2. This x is -2. And this x is -2. So if we substitute, we get negative. We only care about the sign, okay? The number, what number we get, we don't need that. We only need to know where y is positive and why it's negative. So -2 means it's a negative. Because of the square, everything here will be positive at the end. And we have negative and negative. So when we add them, we get a negative. So we have negative times positive times negative. If you multiply these three, what's the outcome? Negative times positive. What's an we get? Positive. And what you're looking for, what type of y? Positive. So we are going to take this in our solution. This is our first solution set. You can look at the numbers, but don't waste your time. We don't need the number. We only need the sign because you're looking for either positive or 0y. So why do we care what type of positive y we have? Okay, then let's go to the next interval. In our next interval, we pick a number between -1 and 0. What number we have between -1 and 0? -1/2. So -0.5. And we are going to replace all these x's with -1/2. So -1/2, -1/2, -1/2. So -1/2, that gives us the first sign negative. And then if we have -1/2, oh, never mind. Because of the square, this term is always positive in the middle. Anything square is positive. Negative square is positive. Positive square is positive. So the middle one we just ignore. How about the last one? -5 minus -0.5 minus 4. We have negative. So we have negative, positive, negative. And the outcome here is positive. That means you're also going to take this in our interval. Am I doing the math correct? -0.5 is between these two, correct? So -0.5 here, 1 minus 0.5 square is positive, and -0.5 minus 4 is negative. Yeah, it looks correct. Okay. Then we pick any number from the interval 0 to 4. Pick anything from 0 to 4. 3. And we are going to substitute all these x values with 3. So we have 3 here, 3 here, and 3 here. 3 is a positive, so we get a positive sign. Pick any number from these intervals. So in the first interval, we picked -2 because it's between -1 and infinity. Pick a number from 0 to -1. They all have to be fractional. So we picked 0.5, -0.5. And now we are picking another number from 0 to 4. We pick 3. We substitute and we get plus, plus, and 3 minus 4 is negative. So in this interval, we have positive, positive, negative. What's the product? Can you take the third interval? We are looking for positive y, but this interval gives us negative y. So this is not in our solution. Now, lastly, pick anything from 4 to infinity. Any number that is bigger than 4. 5. 17. We can do that, no problem. You're going to get the same result anyway with 5 and 17. So 5, 5, and 5. 5 is positive. The middle one is always positive. And 5 minus 4, what sign we get? Positive. So third interval, we are multiplying 3 positive. So what's the result? Positive. Since this is positive, we are going to take this in our solution. That means from the entire number line, everything gives us positive y except the third interval. So the solution we are going to write them as an interval notation. How do you write the first interval? Oh, since the first interval is from negative infinity to negative 1 to 0, and they have no problem. When x is negative 1, we have y0, and you're looking for y0. For every number here, y is positive, we're looking for positive y. For every number here, y is positive, and we're looking for positive y. So we can combine these two intervals. They have no problem from negative infinity to 0. So our first interval is from negative infinity to 0. Do you remember the boundary? What's your boundary to do? Bracket or parenthesis? Bracket. Why it's bracket? Equal sign. Equal sign means bracket. Why did they give me an arrow? This is so weird. We get a bracket. And then our last interval starts from 4 and set infinity. Infinity gets parentheses. How about 4? Bracket. Otherwise, how do you know? How do you know which interval is positive, which is negative? There's actually another method, a simpler method.
So for each interval, we just pick a number that was meant. We plug that number into that.
Because the result you get is the y. So you plug in x to see what's the y value. Because they are looking for bigger than or equal 0. Bigger than 0 means positive y. Equal 0 means 0y.
Okay, so it depends on
If it was less than 0, then our answer would have been only this one. In the exam, I'm not going to give you this long thing because you don't have time. But in the homework, yes. They are part of the exam, but I'm planning to give you quadratic, so you don't have to do all the math. Quadratic, just use graphing. If you don't use graphing, you have to show all these things. If you don't show anything and suddenly give me the answer, you're going to get 0. So in the final, either you're going to get a quadratic or you're going to get rational. Even for rational, you're going to use the number line, test every interval. So either way, you have to know this for the final. So rational, it means we have a fraction. And whenever you have a fraction, use the number line. But before using number line, you have to bring everything to one side so that you have only one numerator and one denominator. So bring everything to one side, combine all the fraction, and try to factor the fraction if possible. Can I flip my page? Okay, so for rational, it's almost like non-rational, but the difference is the denominator. So in rational, what we do is we combine everything to one side, and then we get one numerator, one denominator, and we factor everything. Once you factor everything, you set each factor equals to 0, just like this example. Anytime we have all the factors, set each factor equals to 0. Which one? Which page? Set each factor equals to 0, solve for x, because they're going to give you the x-intercept, the numerator, and denominator going to give you problems. So we cannot have 0 on the denominator, remember? So we look for what x value makes the denominator 0. We cannot have them in the solution. That's why for denominator, we have to use parentheses. Parentheses means do not use the number next to that. So every denominator and infinity, they always get parentheses, and based on your inequality, either numerator get parentheses or square brackets. So numerator depends on inequality, but denominator, it doesn't matter what type of inequality you have, it's always parentheses, always. Can I flip my page? One example, the easiest one. We have a rational function 7 divided by x plus 7, and you're looking for the negative part of this function. Which part of this graph has a negative part? Means which part of this function is lying below the x-axis. This is what you're looking for. Unfortunately, we don't know the graph. If we knew the graph, all life would have been easy. Since we don't know the graph, our hope is the number line. So here we have nothing to factor, nothing to combine, because it's only one numerator and one denominator. Also, our numerator doesn't have any variable. Since numerator doesn't have any variable, just ignore the numerator and go to the denominator straight. We know x plus 7, we know denominator cannot be 0. That means this x plus 7 cannot be 0. If you subtract 7 from both sides, x cannot be negative 7. So the information we get from the denominator is, whatever you do, do not take negative 7. This inequality is telling us, hey, look for negative y only. No 0y, only negative y. Now we have to test the number line. Since we have only one number to test, we substitute. We plot that on the number line. We have negative infinity, positive infinity. Our numerator is always positive, right? Because it's a positive 7. So all you have to do is check the denominator. So let's pick a number. What number you want to pick between negative 7 to negative infinity? Negative 1 is bigger than negative 7. Negative 8. And you substitute this x with negative 8. Negative 8 plus 7. So you get positive over negative. What is positive divided by negative? Negative. And what you're looking for? Negative. So this interval goes inside our solution set. We are not done because we still have another interval to check. So we have to check the next one. Any number that is from negative 7 to infinity. In other words, bigger than negative 7. My favorite number would be 0. So we get positive over 0 plus 7, which is positive over positive, and this is positive. So this one is not. Go ahead. I'm picking a number from the number line and substituting in the function. That's it. Why do you see negative 7? X cannot be negative 7. So whatever you pick, you cannot pick negative 7. Any number before negative 7, any number after negative 7. So pick anything before negative 7, means smaller than negative 7. We pick negative 8. You can pick negative 10, negative 100, negative million, it doesn't matter. Just pick anything that is smaller than negative 7. Once you pick that number, substitute here to check the y value. So we have 7 is positive, and on the denominator we have negative 8 plus 7. We are looking for negative. So once you substitute, if it's negative, that goes inside the solution. If it's not negative, that doesn't go inside the solution. Because our solution set says only look for negative y. So what is our solution? From where to where? Negative infinity to negative 7. And what type of boundary are we supposed to give to negative 7? Parentheses. We got negative 7 from the denominator. So it doesn't matter what type of inequality we have here. Denominator always use parentheses. So what it's saying is that if you take any x value from negative infinity to negative 7, you're supposed to get this result positive. Means this portion of the graph is lying above the x-axis, but do not take negative 7, because when you have x equals negative 7, this function doesn't exist. So in reality, let me show you the graph. The graph, if this is negative 7, we have a breaking point at negative 7, and this portion of the graph is lying above the x-axis, and this portion of the graph is lying below the x-axis. This is the picture of this graph. So we found out everything from negative infinity to negative 7 is lying, sorry, it's negative, other way around. My bad. So this portion is lying below the x-axis here, and this portion is lying above the x-axis. So this is the part where they're asking us to find negative y. So if you know the solution, if you know the graph, see, it's easy. You can see directly. But if you don't know the graph, you have to find it manually. But this is too easy. So in the final exam, usually they are asked this question. What they ask is something like this one. It looks kind of harder. It's not actually harder, it's just more work. Remember, we are solving the inequality. Anytime you're solving something, what's the requirement? What do you have to have? Equals to 0. Or at least you have to have a 0 on one side. That's the thing. Do you have 0 on one side? So what is our first step? Subtract x, add 2. No, we have 6 over x plus 3. This is a fraction, and we are adding, my bad, you're subtracting x. We are subtracting x, and we are adding 2. Let me get more space. I need more space. We're subtracting x and we are adding 2. And we get bigger than 0. Right? And now you're going back to chapter 7. How do you combine fractions with non-fraction? What do you need? Anytime you're working with fraction, you're adding or subtracting, what do you need? Same denominator. So what is our LCD here? We have only one denominator, so that must be our LCD. So we want x plus 3 here. So you multiply numerator and denominator by this. We also want x plus 3 on this denominator. So you multiply numerator and denominator by this. So now all the denominators have x plus 3. We are happy. We write it once and we combine our like terms. So let's combine. The first numerator is 6. And then we have negative x times x plus 3. And we have 2 times x plus 3. Bigger than 0. I did nothing new. I brought everything to one side. And using knowledge from chapter 7, we need to add them. So add or subtract. So we need the same denominator. So multiply numerator, denominator by whatever we need. Now, what do we get when we add the numerator? What do we get? Negative x squared here. And then negative 3x plus 2x plus 6 over our denominator, x plus 3. And then we combine like terms. So let's see what like terms we have. We have 6 and 6, one like term. We have negative 3 and positive 2, another like term. And our x squared is alone. So negative x squared. And how many x's? Negative x. And what number we get constant? Plus 12 over the denominator x plus 3. And since our polynomial started negative, what do we do? Anytime your polynomial starts with negative, what did I tell you to do? Factor it out as a common factor. So negative x squared plus x minus 12 over x plus 3. Now, is it factorable? X squared plus x minus 12. Can you think of two numbers multiplied to 12 combined to 1? 4 and 3. Give me their sign. Positive 4, negative 3. And now we completed our factoring. So first step, bring everything to one side so they can combine. After combining, if it's factorable, factor. And then what do we do? We do not cancel here because there is nothing to cancel. We're looking for x-intercepts. Once you have anything factored in inequality, the first step is always looking for your x-intercept. So to find x-intercept, we take each factor, set them equals to 0, solve for x. So the first one is negative x plus 4, 0. That tells us x plus 4 is 0. That tells us x is negative 4. The next x-intercept is x minus 3. So that tells us x is 3. Now, denominator doesn't give us x-intercept. Denominator gives us problem. What we cannot have. That is what denominator tells us. The denominator is telling us, hey, this thingy cannot be 0. And if you subtract 3 from both sides, x cannot be -3. So whatever you do not use -3. Do not take -3. Do not substitute x with -3. This is what it's telling us. So we are crossing x-axis twice, once at -4 and once at 3. And -3 cannot be in our solution. So our graph breaks down at -3. And now what are you looking for here? What type of y? Positive y. So you're looking for positive y, only positive y, not 0 y, only positive. So let's check our number line. So let me write this down so that I don't have to keep writing it. We have minus x plus 4, x minus 3 over x plus 3. So you have negative infinity to positive infinity. And then we have 3 numbers to plot. Which number is supposed to plot first? We have -4, 3, and -3. What should be the leftmost point? -4. The next number? -3. You're plotting down the number line, so your order must be matched with the number line. And then you do the same thing what we did for the first example or the last example. You just pick a number from every interval to see which one gives us positive y. So what type of x value you want to pick from -infinity to -4? -6. So let's substitute all this with -6. -6, -6, -6. And we don't care about the number, okay? We only care about the sign. So we have first negative. And from the -6, +4, what sign we get? Negative. And then -6, -3, negative. On the denominator, -6, +3, negative. So we can cancel one of the negatives. And we have 2 more negatives. What is negative times negative? Positive. And what type of y you're looking for? Positive. So we are going to take this interval.
Whatever on the right side of the chart. What we need is positive.
Not positive or negative. It depends. You're going to find only one thing, either positive or negative, because inequality gives us only one of them. So it's bigger than 0. It means positive. Then we tag the next interval. Pick anything from -4 to -3. 2 is on the right side. -2 is on the right side of -3. What type of number you have from -3 to -4? Fraction. X equals -3.5. So let's replace all these things with -3.5. -3.5, -3.5, -3.5. So first one is negative, we see. And how about the first factor? +4, -3.5. 4 is bigger, our answer has to be positive. And then we have double negative. When you add negative, you get a negative. On the denominator, -3.5, but +3. Which one is bigger? Negative. So you can cancel one of the negative, and you left it positive times negative. Negative. Are you looking for negative? So you cannot take this interval. Then let's take our next interval. Any number from -3 to +3. Which one you want to pick? 0 or best number. So let's erase all these x values and substitute them with 0. 0, 0, 0. So first one is negative. How about 0 plus 4? Positive. And then 0 minus 3. It is my double negative. So 0 minus 3 gives us negative. And denominator is 0 plus 3. Positive. We can cancel the positive and we left it negative times negative. Positive. So we are going to take this in our solution. Another last one. Any number that is bigger than 3. No problem. Let's take 62. Anything is fine, no problem. So if you substitute 62 here, 62, 62. So first is start with negative, and then 62 plus 4. What sign we get? Positive. 62 minus 3. Positive. And then 62 plus 3. Positive. We can cancel one of the positive, and you're left with positive times negative. It's negative. So can you take the last interval? Now it's time to write down our solution. Sure, go ahead, tell me. Mm-hmm. 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 Perfect. Now all this work takes long time, right? There is a shortcut you can use only if you can remember correctly. There is a shortcut. But let me tell you anyway, in case you can remember during exam. The shortcut is very simple. What you have to do is just test the first interval, and you don't have to test the other. The other will follow the first interval. What does it mean? So when you look at each factor, if all the factors have odd powers, then the sign will change. But if the factors have even power, then the sign will not change on the left and on the right. For example, here, x plus 4 has a 1 power, x minus 3 has a 1 power, x plus 3 has a 1 power. All these factors we have, they all have odd powers. So if you test the first interval, then everything else will change the sign. So first one is positive, we tested. That means for the next one, it will be the opposite, negative. And then for the next one, it will be the opposite of negative, positive. And then for the next one, it will be opposite of this one, so it will be negative. So they will keep switching sign if you have all the odd powers. But if you have even powers, for example, here, this x has 1 power, odd, so it's going to change the sign. This x plus 1 has even power, so it's not going to change the sign. And then when you go to the next one, x minus 4 has a 1 power, so it's going to change the sign. So -1 will have the same sign on the left and on the right, but everything else they will switch sign. So when you plot them, start with the first interval. First interval is -1. And remember, -1 not going to switch the sign because it has even power. So we found -1 in this interval is positive. So next one must be positive. It's not going to switch the sign because this -1 has even power. Now after -1, we have 0. And this 0, x has 1 power. So it has to switch the sign. So after 0, before 0 we have plus, after 0 it must be minus. And now here we have 4, x equals 4, it has 1 power. So that means you have to switch sign. So before 4 you have negative sign, that means after 4 it has to have opposite sign, positive. So you just check one interval and the rest you just follow by looking at the sign for each factor. This -1, we got this vector from this vector x plus 1. So this x plus 1, whatever we get from here, they will have the same sign on the left side of 1 and right side of 1, -1. So -1, left side is positive, right side must be positive. And then the other two, they have even odd power. So whatever we have here, whatever we have on the left, they have to be the other side, have to be the other side. So before 0, we have plus. That means after 0, we have the minus. For 4, before 4, we have minus. That means after 4, we have to have plus. That's the simplest. The simplest you can get, the simplest method you can use to get the solution. You start with the first interval. Like the first number. Pick anything. So first you find the x-intercept. Okay. So this is your method to do. Find all the x-intercepts. Now for checking, you don't have to check 100 times. You can check only one time, and then the sign will follow. So for the x-intercept, you first find the x-intercept, plot them on the number line in order. Because when you have x plus y, you have even power, right? So from the even power, when you solve for x, you get -1. So that -1 has even power. That means -1 on the left side and the right side, they have to the same sign. That one. Only for even power. If you have any even power for that number, the left and right must be the same sign. But if you have odd power, then the left side must be different from the right side. For example, this 4, when you solve for 4, this factor have 1 power, right? We get 4 from this factor. So x minus 4 equals to 0. And you solve for x, you get x equals 4. Now this factor have even odd power. That means before 4 and after 4, you have to have 2 different signs. Look at x. This x is 1 power, and we get 0 as x-intercept from this x. That means before 0 and after 0, you have to have 2 different signs. And observe here. Before 0, you have plus, after 0, you have minus. Look at 4. Before 4, we have minus, after 4, we have plus. Okay? But only thing different is the -1, because the factor from where we got the -1, that factor has an even power. So even factor, whatever x value it gives us doesn't change sign from the inequality. If you like an equal sign, it's bracket. Equal sign gives us bracket, no equal sign gives us parenthesis. So if you don't remember, no problem, but I'm just telling you because this is the simplest method you can use to get the solution. But you don't have to remember it if you don't want to. You can always work with number line and test each interval. The last question I'm going to skip. Instead, I'm going to do a little review. So this one is same thing, okay? So I'm going to skip that. Not same, a little bit different, but I'm going to skip that and let's do a little review. Any question on inequality? So in the exam, I'm going to give you an option, either rational or quadratic for this exam, because you don't have much time. But in the final exam, there is no option. They will give you one of them, and you must do it. They might give you quadratic, they might give you rational. Okay, question. Okay, now let me tell you what will be in the exam. Now, like I said, this exam is a little bit longer than the last one. Okay, so on 7.6, one question. From 7.7, one question. From 8.2, two questions. And let me tell you what will be exactly in the exam. This one and this one. So from 7.6, one question. 7.7, one question. 8.4, two questions. One is joint variation, and the other one is joint variation but multiple choice. But in this joint variation, I'm going to give probably this type of function. Okay, so function could be others or different functions, but the scenarios are same. Now from here, remember 20 points from A. 20 points. Huh? The table. And solve for X, one of them. A will be 20 points.
Like for example,
the table.
you just gotta find a discriminant.
I'm going to give you the discriminant.
So,
And
so don't don't be dumb.
for solving for X, one question. So either you have to use a quadratic formula or complete the square. It will not be factorable, okay? Either quadratic formula or complete the square. Factoring, we already did that. So this time I'm not going to give you factorable polynomial. It will be quadratic or complete the square. Now, definitely one from these two. One of these with fourth degree. See, fourth degree. So we have many other degrees, but I'm going to just give you fourth degree. So if you know fourth degree, you'll be fine. Factor, set each factor equals to 0, solve for X. Now, from inequality, one of them, one will be from quadratic, like this, and one will be rational. So I'm going to give you option. You can pick. Do you want to do quadratic or do you want to do rational? But one question. Now, one of these where you're going to use vertex, x-intercept, y-intercept to graph and find the maximum minimum. I mean, tell me what is maximum or minimum. 9 points. The x value is negative b over 2a. And what's the y value? F of negative b over 2a. Now, one transformation. You're not going to do any math here. You're just using vertex to transform. One of these. So here the vertex is already given. All you have to do is find your leading coefficient. So the format is y equals a x minus a squared plus k. and then one of these. So total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total 12 questions, but they're long. So which one are you talking about? So I'm going to give you the discriminant. So let's say -5. If your discriminant is -5, how many solutions you get? 2 solutions. Are they real or imaginary? So remember, this number is under the square root. It's imaginary. Now, is this rational or irrational? Irrational. And then what can you tell about the x-intercept? How many x-intercept you have? You have imaginary solution. So can you cross the x-axis? For imaginary, you cannot cross the x-axis. Only we cross the x-axis really. So if it's imaginary, you're not crossing the x-axis. So do you have any x-intercept? 0. So I'll give you same thing, like different numbers, and then all you have to do is figure out what scenario you have for each number. You don't have to do any math. That's why it's 20 points. So it should take only probably 1 or 2 minutes. Here. So 8 point for 2 of them. 11.12 for A, it's 20 points. For B, solve using quadratic formula or complete the square. 11.3, weird functions, do one of them. Inequality, one of them. Finding vertex, x-intercept, and graph it with maximum, minimum, figuring out that, one of them. Transformation, 1. Find the equation from the parabola, 1, and solve the triangle, 1. Now, since I did not go over 7.7, 8.4, let's do it real quick. So for 7.7, there are 2 types of complex functions. One is this type, where you have one fraction divided by one fraction. Like example here, one fraction divided by another fraction. Or we have multiple fractions dividing multiple fractions. So depending on what type of fraction you have, you use different method. While you have only one function, one fraction over one fraction, let me erase all of this. And let me move this to another page. If you have only one function over one function, not function, sorry, one fraction over one fraction, you keep the top fraction, you change the division sign into multiplication, and you flip the denominator function, denominator fraction. So this is doable only if you have one fraction divided by one fraction. For example, here, keep, change, and flip. So we have x squared plus 10x plus 24 divided by x squared plus 13x plus 44. Change the division into multiplication and then flip the denominator fraction. The denominator, we have x squared plus 7x on the bottom, but here we are going to put it on the top. And we have x squared minus 5x. I forgot my sign, probably minus 36 on the bottom. And now it becomes the simple multiplication, what we did in chapter 6 or something. So you do factor, cancel, rewrite. Okay. The complex we break down into simpler, so we can use simpler method.
Yeah, but
It's so complex because it's a fraction divided by a fraction. But if you make it simpler, it's just a fraction times a fraction. No, its name is complex fraction. Complex means fraction divided by fraction. I didn't do it, it's the rule.
before, but it's just been straight, and that's so we just rewrite.
Exactly. So it's true only if a fraction divided by fraction. It's true. But it's not true if you have multiple fraction divided by multiple fraction. For example, here, this is one fraction. This is another fraction. This is another fraction. So you cannot do keep change flip. Keep change flip works only when you have one fraction divided by one fraction. See here, we don't have one fraction divided by one fraction. We have multiple fractions. So the method I think the easiest is LCD. If you use the LCD method, your life is the simplest one. So what we do in this LCD method is that we find the LCD of all the denominator. LCD of all denominator. So what denominators we have? Let me erase all this. The first denominator is 3, second one is 3x, and the third one is 4. So what's the LCD of 3, 3x, and 4? 12x. And then you multiply all the numerator by that so that all the denominator you can cancel out. So we have 5 plus 2x over 3 divided by 2 over 3x minus 1 over 4. So you multiply all the numerators. 12x, 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 12x. What is our goal? To cancel all the denominators. 3 goes to 12 4 times. 3x goes to 12x 4 times. 4 goes to 12 3 times. So no more denominators. Now you rewrite. What is 5 times 12x? 60x. And then here we have 2x, 4, and another x. So if you multiply all of them, what do you get? Positive 8x squared. On this denominator, we have 4 and 2. So when you multiply, what do you get? 4 times 2 is 8. And lastly, after the cancellation, you have 1 times 3 times x. So when you multiply all these, what do you get? 3x. This is done. But if you want, you can do one more step. The numerator is factorable. So factor. We get 4x is a common factor. We get 15x. Sorry, 15 plus 2x. Right? 4 goes to 60 15 times. Yeah. And denominator, nothing is factorable, so you leave it alone. So if you use LCD method, you're done in 2 lines. That's it. Okay. Now, one of these always come to the final exam, always. So you have to know these complex fractions. Now 8.4, so all of these are same. You just multiply numerator by LCD so that you can cancel denominators. Now for a variation, we have two types of variation. One is direct, one is inverse. For direct variation, we write y equals kx, and for inverse, we write y equals k over x. Now this x will not be x always. It depends on the function. For example, here, they're telling us y is related inversely to square root of x. So y equals k over square root of x. Inverse means it's a fraction. So we are using this one. X is not x anymore because our function is not x. Our function is square root of x. So y is related to square root of x inversely. This is the function for that. And then you substitute y equals 7. We don't know k. And you substitute x equals 4. So we get 7 equals k2. You multiply both sides by 2. So we get our k equals 14. This is the change of rate, at which rate our x and y, they're changing. Now they're saying, based on this rate, figure out what's the y value when your x is 9. So we know y is changing 14 divided by square root of x. This is how y is changing. Now we know our x is 9, so square root of 9. So answer is 14 over 3. So it's an inverse variation. What will be in the exam is a joint variation. It's called joint variation. It's called joint variation because we have inverse and direct happening at the same time. So it's a joint variation. But we go one by one. The first one is saying y is changing inversely with x squared. So y is changing inversely with x squared. With the same rate, y is changing directly with z. So y is changing directly with z. We are putting direct and inverse at the same time with one constant rate of change. K is the rate of change. So you don't have two rate of change, you have one rate of change, but direct and inverse, they're happening at the same time. So the hardest part is figuring out this information. If you know this one, the next is easy. The first one gives us all this information, so you just substitute. So our y is 5. K we don't know, we need to know, so we are solving for k. Our z is 3, and our x is 2. So if you want to solve for k, you need to get rid of this 3, so divide by 3. So you can cancel. And you also need to divide by 2. We have divide by 2, so you need to multiply by 2 so that they can cancel out. In other words, you're multiplying by 2/3 on both sides. So we get k equals 10/3. We just multiply numerator with the numerator and with the denominator. So our equation here becomes y equals 10 over 3. Since 10 over 3 is a fraction, so we can just use one fraction with z on the top, x squared on the bottom. This is same as 10 over 3z over x squared. They're same. But this one looks complicated. A fraction over a fraction looks harder. But if you write this way, it will be easier. And now they're saying, what is y when x is 3 and z is 2? So you're looking for y. We have 10 over 3. Z is 2, so multiplying by 2. And our x is 3, so multiplying by 3 squared. right? Z is 2 and Z is direct, yeah. So we have 10 times 2, 20, and we have 3 cubed, 27. This is our answer, right? Yeah. Now the other one is asking same thing, but don't do any math. Just use logic to figure out what is happening, how each variable is changing. So they are saying same scenario, y is changing. So maybe in the exam, I'm not gonna tell you y is changing. Maybe I'll tell you z is changing or x is changing. So whatever you start with, that should go on your left side. Okay. If I start my sentence with x, x should be on the left side of the equal sign. If I start my sentence with z, z should be on the left side of the equal sign. Whatever variable you start your sentence with, that goes on the left side of the equal sign. So y is changing inversely with x, means k over x. At the same time, it's changing directly with z. So y equals kz. Now they're saying in this scenario, what is happening? Y will definitely increase. So if you want your y to go up, how you need to change your x and z? So if you have y equals kz and you want your y to go up, your z must go up or go down. Which one? Must go up because they are changing directly. If one is increasing, other must be increasing. If one is decreasing, other must be decreasing. So z must go up. Now for inverse, y equals kx. Now if you want your y to go up, your x needs to go where? Up or down? Down, because they're inverse. If one is going up, other needs to go down. So your x needs to go down. So the option here is x needs to decrease and z needs to increase if you want your y to increase. So maybe in the exam, I'm going to give the other opposite scenario. I want my y to decrease. If y needs to decrease, then what will be the scenario? If y is going down, your z must be going down, and your x must be going up. So this will be multiple choice, but this you need to work out. So I'm going to give this one, but with different variables, different functions, okay? Different functions, different scenario. And I think I went over everything else in class. So all the videos, if you forgot what to do, watch the videos. I went over these 3 yesterday, and finding vertex, Monday, Tuesday. So I went over everything here, okay? So your job is to do them over and over and over so that you can do them quickly in the exam. Okay? So good luck, guys. Enjoy your weekend with doing all the math. Well, let me take the attendance real quick. So today is 24. Alexander, I didn't see him. Have a good day. Anna, I didn't see. Anastasia, I feel like I didn't see her today. Bye. Excel was here. Brenda absent. Bye. Christopher absent. George here. Hannah absent. Hodo here. Jocelyn here. Jesus here. Jody here. Kevin absent. Christina here. Lily here. Liz Mary here. Michaela here. Narelle absent. Natasha here. Peyton here. Phil here. Renan here. Sarah absent. Shawez here. Shawez absent. Yusuf here.